Hello everyone, in this video I would like to show how can we use the Siemens PLC S7-1200 controller run as a Modbus TCP client, the Modbus TCP master function, to connect with one Modbus TCP slave to build up this Modbus TCP connection. And I will use one actual controller for this test. So this is the TI Portal version 16, and let's click this add a new device. And in this test, I will use one lowest controller, that is a 1211. That is the lowest controller from this 1200 series controller. And my controller, that is the latest version 4.4. Basically, to implement the Modbus TCP, all those new versions, their function, they are the same. Okay, so this is my controller. But keep in mind, because this is a 1211, that is the lowest controller here, so it only has a 50 KB work memory. So after we implement this Modbus TCP client function, so we can see how large work memory it will take within this controller. Okay, let's click OK. Okay, this is the hardware view. So firstly, we can double click this Ethernet port. And we can set the IP address for this controller. So we can activate this subnet and we can set the IP address for this controller. So in this test, this S7-1200 controller, its IP address is 192.168.1.201. And the Modbus TCP server side, I will use my laptop and I will use the software ModSim run as a Modbus TCP server. And my laptop, the IP address is 1.101. And this PLC is IP address is 201. Okay. And after we set up this IP address, so we need to switch to this system constant. Let's look at one value here. So this is the hardware interface one ID number showing here. So it shows 64, the integer that is 100. This represents this hardware address. So when we use the Modbus TCP programming, so we need to use this number 64. So let's record here. Okay, now we can shift to the programming side. So expand here, program blocks. From this OB1, we can double click. Okay, from here, we can click this add a new block. Let's create a function. And within this function, we can program the Modbus TCP client. Click this, and we can name it. And we can rename this number. For example, we can name it 10 number. We will use the ladder logic. Okay, click OK. And then go back to the main. And then go back to the main. We can drag this FC into the one of the network within this OB1. Our program will be within this FC10. Okay. And to implement the Modbus TCP, we can go to the right side, find out the instruction. So we can expand this communication. From this communication, let's open this others and this Modbus TCP here. And because we are using the built-in Ethernet port from this controller to implement the Modbus TCP, so that's why we grab this function block from this folder. If you expand here, communication processor here, you can still find the Modbus RTU or Modbus here. This is a little bit confused. That's why it's called communication processor. If your controller has other module, that's especially communication module, so that will use this function block. But we are using the built-in Ethernet port to implement the Modbus TCP. That's why we are using this. Keep in mind this. So to run the Modbus client or the master function, so we need to use this function block. Drag to here. Okay, so at here, we can select this menu and we can name it, this is the 101. So this is the instant DB number. This name, Modbus client DB, name it as _1. Or we can name it, this is the read. I will explain this after. Okay, here we can write the comments here. And this is the FC03 read. So, okay. Okay, if this is the first time for you to implement this function, this will be a confuse for you, especially for the left side. Please follow me. I will show how can we do this. Okay, let's firstly set up 1 dB. Let's serve for this connection. So here we can come here, add a new block, and click this data DB, TCP connect. Okay, and this number could be 10. Okay, connect. Okay, here we can name it MB TCP Client, the read. Okay, and keep in mind this data type is very important. So we need to type in TCOM_IP_v4. So keep in mind we must type in this, and once we type in this, it will automatically create this data type. Okay, and here we need to type in for this function block. So this interface, if we recall, this interface represents which Ethernet port we need to communicate. I showed from the hardware that port number is 64. Here it shows HWANY. That is the hex, the data type. So if by accident you type in 100, if you saw that is an integer, you type in 100. So after that, so when we set up the connection, you will see the TCON set up the connection will show 809B fault. So I will show this after. So I will temporarily type in 100. I will show this fault. And this ID number we can set, this is the first one, we can set number 1. And for this connection type here, we will type in the 11 because we are using the Modbus TCP. The background is still using the TCP IP here. 11 we need to type in here, but also we can type in the hex number here, that is a 0B. So we can leave this 0B as a default. Okay, or we can type in again 16.0B. Okay, that is 11, this data. And this active established we can set to 1 because this is a client. So this client need to active to set up the communication. So here the remote address we can set the address. So that is a server side IP address. If my client IP address is 192.168.1.101, so we need to type in here. Let's explain. And in this test, my laptop IP address is 192.168.1.101. So here I will type in the hex number. I will use this calculator transfer to hex number. Okay, I type in here. .101 hex, that is 65. So this is the remote. This is the server side IP address. Keep in mind this. And the remote port, so we will use 501. This is the unsigned integer. So we will type in 502 here. The port we will use 502. Okay, the local port we can use as a default. Okay, remote is very important. Okay, keep in mind this. Okay, this is the setup connection parameter. Okay, and keep in mind all those parameters we are under this Modbus TCP client read, this line here. And then we can float here, click this button, and go back to this function here, and we can drag this variable to here, release. This basically transfers those parameters to this connection here. Okay. And then the Modbus mode. So let's check out the detailed explanation for this. Let's click this function block and hit the F1. Okay, this is the Modbus client function explanation here. So we can see REQ, that's the trigger function. Every time we trigger, so we will trigger the client to read or write the data to the server side. Disconnect, that is enable or disable. If we set 1, we will disconnect that communication. Okay, and this Modbus mode, this is very important. If that is a 0, that is a read. If that is 1, that is a write. Keep in mind, this is the unsigned integer value here. Okay, and here that is a Modbus address. If you recall, Modbus address that is a 1400. For example, 40,001, 40,002. That is a Modbus address. And this is Modbus length. That means how long the data register we need to read or we need to write. Okay. And this Modbus data pointer, that means after we read or write the data to the server, Modbus server side. So where we need to locate the PLC data, this will assign the PLC data here. Okay, so let's go back and let me program. So firstly, this Modbus mode, I will directly type into the 0. 0 means this function block will run the role to read the data from the server to this client side. Okay, and Modbus data address, we will start from the 40,001. So we type in here directly 40. Okay, this is the Modbus address. This is the start address. And the length, for example, we will communicate read 20 register back. Okay, and this is the data we need to store the data. So we need to create another DB. So double click this data block, click this data block. And let's change the name. This is the Modbus TCP read. So this is the Modbus TCP data. Okay, and this number, we can follow this number. For example, next one will be 11. Okay. All right, and here we can create a buffer. So we can create read, just the name as a read. And this data type, we can create array. The array length, that is the word, because we are going to use the function 03 or 16. And the function 03 and 16 read or write will operate the word one register, that is one word. So we will create one array. So like this style, click, and the array, we can start from the 1 and 120, this length. And because this is the data, too easy to operate the data, this buffer, so personally I will recommend from here, right click, click this properties, and go to the attributes and uncheck this optimized block size. So that's some special case we can use the traditional way, and we can use this offside, this absolute position once we got a compile. For example, if I compile here, after we uncheck the optimization, so this DB will show the absolute address here. It's very easy for us to operate, especially if we want to set 1 bit in one word. So to use this, we can drag this DB read to this Modbus data pointer. Okay, we can drag to here. This is the read. Because we are using this Modbus mode, 0 means we are using the Modbus TCP function 03. That is reading the data from the server side to the client side. Okay, disconnect down busy arrow. So we will type in some temporary data. For example, we can come here and we can create some tags here. So we can add a row, disconnect, that is a bool. So I will create the same name as the interface of this FB. If we are using those variables, we can look at the actual status from this client connection. Busy. Done. And disconnect. Okay. By default, this value is a 0, so that we do not need to disconnect this function. And this trigger signal here, every time we give a trigger signal, it will send. So we can use one function from our controller. If we double click this device configuration, double click this controller property, and we scroll down here, the system clock. If we enable this 2 checkbox, so for example, if we are using this 1 Hz clock, if we directly use this M05 1 Hz, so we can directly use that. Okay, if we go back, we will use 1 Hz trigger. So at this REQ here, we can directly type in this M0.5. Okay, it will show clock 1 Hz. Once we download this controller, it will run 1 Hz. This M address will automatically controlled by the controller. Okay, here we set up this connection. But now, actually, we only build up one direction data. This is read the data from the server side to the client side. Now, if I save this project and compile, and now this is only one direction, reading the data from the server to the Modbus client, this PLC side. And now let's look at this program info. Only use this one direction Modbus TCP client. Let's see, now it takes 8K bytes. Keep in mind this working memory. For this small controller, it already took 17% on this controller because totally it only has a 50K bytes here. So this size is a reference. Okay. So here, let me explain a little bit more. So as we know, from this port, Modbus mode 0, that means reading the data from the server to this client. If I read 1, so we can read the data from this client to the server side. Some cases, some people will assign one variable here, so we can switch this 0 or 1, and also associated with this REQ, this command. So we can use one function block here and one instant DB to implement the reading and the writing. That's no problem. That can save the CPU work memory. However, there will be a little bit complex problem here. As we know, when we're reading or writing the data communicating with the server side, this buffer we are sharing used for the reading or writing. So we need to very carefully about the switching the data buffer. So we need to prepare the data for the sending, and after we read, we need to transfer this buffer to a read back buffer. So that is really annoying. So personally, if you are using a higher end controller and if you have enough space, I recommend you use 2 function block and use the different instant DB. I will show after. So this function block especially serve for the reading, and this is the read buffer. And next one we will set 1, and that buffer is especially used for writing. Okay, so let's do that. So next one, communication. Let's drag the next one. This client, because I'm using the TI Portal version 16, so the latest version now, that is the version 5.2. Okay. And I will drag this client again. Drag to here. Pop up this instant DB. So click this single instant because we are using the FC to call them. Okay. So I have to use this single instant. Select this menu, and this time this is the 102. Okay. I will rename this instant DB Modbus Client DB write. Okay. And I will select this number 102. So here I will write this command Modbus TCP Client Master FC16 here write. So to implement this FC16 write, so the Modbus mode here I will write 1. 1 means write the data. And this REQ here, so we can use here, we can click this. We can use this signal is on or when it's off to trigger the Modbus client reading and writing. And when this signal on, we can read the data. And when it's off, we can write the data. Okay, so we can use a similar way, program like this way. So when the signal on, it will trigger reading, and this off, it will trigger this writing. And then let's configure this connect. So let's open this DB10, this Modbus TCP connect. And let's create a second one. That is a Modbus TCP client write. Okay. Actually, we can copy this. Copy. Paste. Rename. That is a write. Okay. The date type. Keep in mind the date type still TCOM IP v4. And this ID number, we're still using the same hardware port. That's the 100 integer number. So 64. And this ID, we can change the second one. Okay, keep in mind the ID number, we are using the different ID number. So connection type is still the TCP. So connection type still the TCP 0B, that is 11. Okay, and active established still the active side, that's 1. And remote address, this is this. So the IP address 192.168.1.101. Okay, and this remote port, that's still 502. Okay, and then following the similar way, we will declare some port here. Okay, we declare here. Then we can drag them to this function block. Okay, and then this Modbus address. So when we read the data from the Modbus server side, so that address we start from the 40,001, and the length we set to 10 here, and the reading we can start from the 40,020, and its length still can be the 10. Okay, so here we can type in 40,021. Okay, and the length we can, this is 10. And then this connect, so we can drag this Modbus TCP client right. Based on this data type, we can drag to here. Okay, and this PLC local buffer, so we need to declare one new buffer, that is a write buffer. So we double click this DB11. We can create a new line here, and we can name it write. So this is an array 1 to 120 word here. Okay, float, come here, we can drag this write to this port. Okay, and because this DB, that is a non-optimization DB, so by default it shows question mark here, and once we compile it, it will show OK. So let's compile. And now we have a two function block here. One is especially for reading the data from server to the client. One is writing the data from the client to the server. Okay, and because we just programmed this second function block, and now let's check out this program info. It basically takes 10.5K bytes within this working memory. So for this smallest controller 1211, it takes 20% on the working memory. So this value can be a reference for you. Okay, now we can download this controller. Okay, so the software, we found this, so we can download. Okay, let's start this controller. So our PLC will be started. And to test the data, we can use the watch table. And let's create one watch table. And at here, we can open this DB. So our actual data is within this read and write, right? So we can drag part of those data. For example, the reading. So we can drag the 15 buffer to this watch list. Okay, and here we can drag the write 15 here. The length we set to 10, so we drag 15, that will be enough. Okay, next, let's use the ModSim software run as a Modbus TCP Server. So to download the software, we can browse this website wintech.com and browse this ModSim 64, this software that run as a Modbus TCP Server software. Okay, after we download the ModSim 64, this version, so we can double click this. And this is the demo software, okay? So click OK. Click OK. Click OK. And we can set up this server, okay? And the address, we can start from 1. And the connection, we can select this Modbus TCP Server. And the port, that's the 502. And my laptop is 192.168.1.101. So my laptop will run as a Modbus TCP server. Okay, so it's ready here. So this is the PLC side, and let's look at the current status from this function block. So it shows error, and the code shows A09B. So we can search this code. So we can find out F1. And after we search this code, A09B, and we can find out basically this code comes from the local device ID setting. So if we go back our program and we double click, that problem comes from one setting from this connect. So that connect comes from the DB10. Double click. And this setting, setup connection setting. So if we expand here and we click this online, now the value shows 100 here. Here we need to set 64 direct to this HW. So that is a direct hex number here. So at here we need to type in the direct 64. So we can also change here 64. We can change here 64. And we can change this, also change for 64. So keep in mind this. And this number comes from the device configuration. If we double click this port, click this system constants, and this is the interface number 64 is here. We directly type this 64 to here. Okay, so let's download this new setting. Okay, now we haven't set up this client yet, so it shows 7002. Okay, now click this new. And let's select this Modbus TCP Server. And now let's set this address with start 1. And here the device ID for the Siemens by default, we need to set this device ID to 255 here. Okay, we need to set a 255 here. I will explain this after. And now let's click this watch table. Click this monitor. And this is our read buffer and the write buffer. And now from this 40,001, so we can double click, and this is the decimal, so we can type in 1234. So we can see the hex number is receiving here, so we can change this style into the hex. So we can switch to the hex. Now we can see 42 it received there. So next one we can type in AABB. So we can see AABB received here. And from this write area, hex number here, we can write 3344, for example. Write, enter, and transfer. So we can see 3344. We start from the 21. It received here. So 3344. So from the client, it write this 3344 to this server. So next value, 1122. Right? So 1122 here. So because we write 10 value, so we can test this 10. So write CCDD. And next one, we can specially test this 11. This 11 shouldn't send to this server. So we can transfer. So this length, we send the 10 register. So we can see only CCDD here, we send to here. And this EEFF, because that is the 11th, so this EEFF will not be sent. So we can see the value can be read from this server to this client correctly. And this value can write from this client to this server correctly. And this device ID is very important. If now I use this default, for example, 1. If now I write the data here, for example, if I rewrite this data, if I set this 3 here, let's say 1122. So we can see this value we write here, and here it doesn't show up. If I write the new value to here, 1234, so we can see the 1234 cannot send correctly here. So let's explain this device ID here. And let's open one instant DB. Okay. For example, this DB101. We open it. And from this instant DB, if we click this monitor, And there's one value here. It shows Modbus unit ID. For the Modbus TCP communication, sometimes it will care about this. Some Modbus TCP server devices, they will not care about this UID number. But some vendor or some manufacturer, when they provide these devices, inside the devices might be the 1 or the FF. In Siemens, this number default, that is FF255. You can write this value to 0 or to 1 to match with your server side. And in this case, for example, if now I write this value to 1, that is the hex 1, but the integer also equal to 1, right? Also, we can minimize this and open this next InstantDB. Open. Monitor. And right here, we can write to 1. Okay? And keep in mind, this value will not be retained. So we can use the move directly write this MB unit ID. So let's temporarily test that first. So we write 1. Now let's go back to the server side. So once we shift here, so we can see this 1, 2, 3, 4 wrote correctly now if we are using the device ID 1, because we changed that to InstantDB, change to 1. Okay, so if I change the value to do a verification here, let's do 7894. So, right? So we can see now it's communicating correctly. Now, if I give a new value from this server side, let's say ABCD here, we can see ABCD is read correctly from this client side. So we are using 1 because we changed that unit ID from this client side. So that means we set up this Modbus TCP communication correctly. Alright, as we discussed, since the unit ID cannot be retained inside the InstantDB, so we better use this move directly write the value into the unit ID. We will write this 1 to that unit ID. So we can open this InstantDB. How to open it? So we can go to the system block. And there's two InstantDB. One is 101, one is 102, right? So here, from this system block, open this DB 101. And we can flow that here. Scroll down. So find out this Modbus unit ID here. We can see default start value, that is FF. So we can drag it to here. Okay, so using this way, we can write this 1 to this unit ID. Okay, so using this way, we can directly write this InstantDB. Okay, and we can write the comments here. So this is the unit ID. Okay, that is the Modbus TCP Client function in the Siemens S7-1200 PLC. The S7-1500 PLC, there will be the same. And basically, from this program, the reading and the writing these two function blocks, we can use this project as a template. Alright, that is for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.